Hello and welcome back to the class R for Journalists. We are now going to the next section in our introduction to R, and we are going to talk about what happens when you don't have data at all. So when you work with real data, you will encounter missing values because maybe instrumentation failed or because there wasn't a complete survey filled out. So when you deal with data that's not available in R, that's represented as an NA. So instead of a 0, you get an NA because the lack of data doesn't automatically mean a 0. So for example, if I create an object called J, combine 1, 2, and NA, it will look like that, 1, 2, and NA. So R automatically knows that NA, there's no data there. It's just kind of blank. So computing statistics of incomplete data is not easily possible. And that's because if you're trying to run statistics on incomplete data, statisticians they'll say, why would you want to do that? It's incomplete. So if I tried to run the function to find out the max number of something, the function is called max, and I run it on J, it won't give me a 2 or anything. It will just give me NA because it's like, no, I'm not going to give you the results because your data set is incomplete. So if you don't mind missing data and you want to compute, if you want to figure out the math anyway, you can add the argument max. You can add the argument na.rm equals t for true. That stands for remove NAs from this function, ignore them, and run the function anyway. So now when I run it, I get a 2. So this is just to warn you that NAs will mess up your math unless you're careful. And I mean, that's not horrible. It just makes you more aware that, yes, you have some incomplete data. Okay. I've included more links in the walkthrough to help you deal with missing data. So let's move on now to classes. So we've been working so far with numbers, but sometimes data we work with can be more specific to something else, like characters and strings, or Boolean values like true or false, or even dates. So let's start with characters. Characters are pretty much strings. So we've got M is apples, and there it is in my global environment. And when I run M now, there it is, there's a string. So to tell R that something is a string, you just put it in quotation marks. You can't pass it something that's not in strings, because it assumes this object is in here. It assumes that instead of a string, it's an object that you're passing it. Now you can pass an object to another object, so this will work. See that apples and apples now are in there? So when I type N is also apples because I was telling it, so apples is M, and because apples is M, I want you to also be N. And that's that. So you can't do math with characters, sorry. Nope. Okay, next type of class of data is dates. You'll be working with this once in a while in R. It's good to just deal with it, know how to deal with it also. So dates and times are complicated. So R has to know that 3 o'clock comes after 2:59 and that February has 29 days in some years. The base way to tell R is a date-time combination is with the function strp_time. That's the function. So let's pass it an array of, I'm going to copy and paste this code in from my code through because it's quite long. So this is, you can recognize the year, the month, the day, the hour, minutes, and seconds. Okay, so you start with that, and then you have to tell R with this function what to do with that, how to parse that. And so you do that by doing format equals, and you do like %y, %m, %d, %H, %M, %S. And it's lowercase or uppercase depending on like whether it's abbreviated or not. So it's quite complicated, but now I have date 1. And it has restructured it. It says it's POSIX LT. So this is correct. What we're going to learn later on how to use to deal with data is Lubridate, the Lubridate package. It's a little bit more intuitive to use in the sense that the command is something different. It's called YMD HMS for this one, because instead of passing the format through here, you're telling it what the format is based on the function itself. So this might blow your mind now, but we'll go over it later on in this section when we deal with dates. So you see date 2 is also the same thing. Okay. Next, let's talk about factors. Factors are complicated. So it's a data structure specifying categorical or nominal variables. And factors tells R how to handle this specific type of variable in analyses, which is very important, but also misunderstood. So any variable that is categorical or ordinal should usually be stored as a factor in R. Usually you think of it as strings. For example, race might be input as white, black, and Hispanic. And when importing data from a spreadsheet, R will often interpret it as a factor automatically because statisticians. So let's run these lines of code that I have in here. You'll see that. Let's copy that over. And I pretty much, so every line is an array. Well, except for this one. This one actually is creating a data frame from arrays. So let's just take a look at what that created. This is the data set, the data frame. Let's take a look at the structure of it. Okay, so R sees that race is a column that is a factor with 3 levels. And so let's check the levels. So we run the function levels, and we pass it the name, the object, the name of the data frame. And to refer to a single column in your data frame, you just use a $sign. And then, what was it? It was race. Oops. Okay, so you see it is in this level of black, Hispanic, and white. And it orders it based on it's alphabetical, unless we specify it. And we can specify it later on. So let's take a look at summary of sample df of that race column. And it shows that there's two whites, 1 Hispanic, 1 black. So this is important to kind of realize about factors. Internally, R stores the integer values as 1, 2, and 3. So black is 1, Hispanic is 2, white is 3, because that's just the order of it. And it maps character strings to that. So 1 equals black, 2 equals Hispanic, 3 equals white. Why is this important to know? The thing is, journalists are less concerned by factors and will often find themselves converting factors into strings and characters. I do that all the time. But when you reach the point that you are wanting to make models and linear regressions, you'll be happy that race is as a factor is an option. But we'll get to why these factors are kind of stored as numbers in the background in a little bit as when we're converting it. But for now, let's talk about integers and numbers. Integers and numbers are what they sound like. They are whole or decimal numbers that can be used in calculations. So R doesn't handle units properly if they are combined with numbers. For example, 4 inches for yn will be treated as a string and not as a 4. So now we can go back to converting between different types of classes of data. So, 1. You can convert factors into strings. So let's take a look at sample df race again. And to convert that, I just run as.character sample df race. And now it went from, now they're surrounded by quotation marks to signify that those are strings. I can create a new column with this kind of function. I'll call it race converted. And I'll run the function again as.character sample df race. So now when I open up sample df, there's 5 variables. And when I look at the structure of it, you see race is factor, race converted is character. Okay, and vice versa. You can convert strings into factors. So here's name. Let's convert this. And the function is called factor. Sample df. So let's convert names into factors. So now there are 4 levels. There's levels of Dwight, Jim, Pam, and Steve, because that's alphabetical. And those are the 4 factors out of that. Okay. So we've done strings to factors, factors to strings. What if you want to convert factors into numbers? Let's run that on, let's see, where is a factor field? There's ID we have in our data frame. That's a factor. Let's try to convert that to a number. As.numeric is the function to convert that. And sample df ID. Aha! So ID up here is 1001, 1002, 1003, 1004, but are interpreted as 1, 2, 3, and 4. Why is that? It's because of that levels thing I was telling you about. Because R source factors as integer values. So you must convert factors into characters first before you can convert it to numbers. It's a weird thing, but you just gotta embrace it, okay? So sample df ID. So first we want to convert that to as character. This way we take out that whole like storing of numeric things. And then we're going to nest that with as.numeric. Because you can convert characters into numbers as long as there are no, as long as they really are numbers. If there's any characters in there, then it will just disappear. It will turn into NAs. But, so this is how it works. We got nested. We've got first, it'll run kind of like math. It'll run the thing that's inside first, and then it'll run the thing outside afterward. So now when I do that, these are now numbers. You see, because it's no longer in quotation marks. Okay, so the last thing I want to talk about before the end of this video is functions again. I want to revisit that concept. So you can save code you've written that simplifies your process and your data analysis into a function. This is a way to like make your stuff reproducible much easier. So for example, if I wanted to create, figure out percent change, let's say I'll just do first number and assign it 10, second number, assign it 8, store that, save that into our global environment, 10 and 8. So how do you calculate percent change? That is second number minus first number divided by first number, and you multiply that by 100. So percent change between 10 and 8 is negative 20%. If I'm trying to do this often, I'm going to have to write that out every time. I can say this is a function. I'll show you how. I'm going to create the function name called change, percent change. You don't have to kind of understand how this works right now. I just want to show you how it looks like. So I'm going to run this code first, and it is now saved as a function in my global environment. So now I run the function, I type it out, and I pass two numbers. So I'll try, the first number will be 100, and the second number will be 80. And I get minus 20%. So let me explain what happens in this code. So %change is the name of the function, and it is assigned to the function. And then two variables are necessary for this to run, the first number and the second number. And then a new object, PC, is created using some math calculating %change, kind of like I did this first time. But this time I save it in this function. Okay, and then I use return so that it preserves the number that was created in this function, and it passes it outside. So now when I run it, it will run. So if you build enough functions, you can save them over time and save them into like a collection. And that will be a library or a package that you can share with others. So the important thing about functions is that they're programmed by humans. So I constructed this function because that's how I know that I'll include two inputs, and that each one will be numeric, and that they'll be in order of first and then second. If you're working in R and a function you're using is giving an error, it most likely means that there's something wrong with one or more of the variables you're passing to the function. So here's what happens when I pass a string to this %change function. It says error, second number, non-numeric argument to a binary number. That's pretty vague. So sometimes really great R programmers will anticipate errors and catch bad inputs and try to output helpful suggestions instead of a generic error like that. So this particular error isn't explicit, like I said. It needs to be interpreted. But we know that the function needs numbers to work correctly because we saw it be constructed. I broke it down for you. New users might not know that intuitively, and that's how you're going to feel when functions you run don't work. You'll have to Google the error or peek into the code to see how it runs and see what it expects and how it might break down thanks to what you tried to give it. And it won't be entirely your fault. When you're coding and sharing it for others, we can't anticipate all the ways in which others might want to use it in the future. And so you can shoot the function writer a message to say, hey, what's up with this? Or give feedback, and they're usually always welcoming of it. And this is what makes participating in the R community so great. Just this feedback loop. Because we all want to do better and improve on things. So, we've gone through a lot of things in this particular video. All the classes of numbers, we revisited functions, we talked about dates, we talked about what to do when you have incomplete data sets. So, hope you've had some fun. Let's move on to the next section.